Hey, this is Keith Robine from Kootenai Avalanche Courses. We're here at Kootenai Glacier.
You have volume now?
Working on an avalanche course with
Sweet.
a group of
Okay.
athletes from Outdoor Research.
We're seeing it now.
And they're just getting ready for a film shoot, but I wanted to talk a little bit about the snowpack. It's been really interesting start of the winter. Things are actually getting pretty good in terms of skiing right now. And we've been tracking what we call a persistent weak layer that was laid down in the middle of November. We had a whole bunch of dry weather, and during that period surface hoar formed on the top of the snowpack, and now it's been buried. It's about 50 centimeters deep. People have been experiencing a lot of cracks and woofing when the snowpack has settled, but we haven't had a ton of avalanches on that layer. And part of the reason is that it hasn't really compacted enough. Well, we just had 30 centimeters in the last day here at Kootenai, and so now we're starting to get enough weight on that surface hoar layer that it's really starting to wake up. And I don't know if you can see behind me, but we've been getting all these sympathetic releases. Very cool. And I don't know if you can tell, like, as they're coming down, there's lots of little avalanches on the steep rolls that are breaking, like in some cases 5 meters away, but in other cases they're breaking like, 50 meters away. We're seeing cracking and small avalanches coming off. Hey, this is Keith Robine again from Kootenai Avalanche Courses. We've been talking about this persistent weak layer that was laid down around November 21st, 22nd. It hasn't been super active except causing a lot of cracking and woofing. Now we're starting to see some avalanches, and I don't know if you can see very well behind me, but we just triggered that avalanche and we're like over 50 meters away from it. So it just shows the reactivity of that layer. So in other words, we collapsed it underneath our feet right here, and then that collapsed layer, like dominoes, traveled along the snowpack up into that zone up there and collapsed the layer and caused a little avalanche. We've also been talking about choosing the right terrain for the conditions, and today we're staying out of big avalanche terrain because obviously we have this instability and it would be super dangerous. So we're avoiding all of that kind of terrain up there or anything similar, and we're sticking to lower angled slopes that are generally under 30 degrees and having a great time because the skiing's amazing.
Yeah!
All right, now can you hear me? Okay, good. Somebody say something so I know that I can hear you.
Yeah, we can hear you.
Okay, good. Yeah, it's just like so messed up. We were having an issue the other day, so I have to like unplug my thing so I can't actually hear it, but you guys can hear it, which is the most important thing. So it's all good. All right, so I'm not gonna go too much into this one thing that you've already seen, but this is hopefully familiar to everyone. I know it is for Tom and Seth and Tandy, Danielle and Jeff. Yes, good. Sweet.
Yeah.
And so just as a review, like, I mean, obviously we're gonna go into greater depth than just the trip planner. However, despite 30 plus years of doing this, it's not that I pull this out every day. I've got it memorized. This is how I choose terrain. This is exactly how I choose terrain. When the danger's high, I'm generally sticking to, simple terrain. I feel pretty comfortable skiing simple terrain because I know what to look for in terms of, avoiding slopes that can cause problems, right? Because basically in simple terrain, it's relatively easy to avoid, say, a small slope with a terrain trap, which you might run into. But I know what to look for. I just avoid it. Avalanches or natural avalanches, blah, blah, blah. I'm also quite aware of overhead hazard. And that's generally what I ride. I'll even ride simple terrain and extreme terrain. Knowing that I'm just basically avoiding stuff and just really aware of potential overhead hazard. This is set up this way also. It might be a little bit Revelstoke centric, this tool, because it was, designed, through Avalanche Canada and that sort of thing. The terrain is big there, right? So anywhere in Rogers Pass, even if it's simple terrain, you're probably having to cross a big slope or something somewhere. And so, it makes sense to just say, go to the ski hill. Okay, so then when we get into considerable danger, things get very interesting because we have all three colors, right? We've got green, yellow, and red. And simple terrain should be relatively straightforward. You still have to use caution, right? Green isn't like go out with blinders on. It just means use normal caution. Just be aware of what you're dealing with. Overhead hazard, terrain traps. Those are the things that are going to get you in trouble in simple terrain. That's it, right? You shouldn't be getting into big avalanches because then it's not simple terrain. Then it's challenging terrain, maybe, or complex. In challenging terrain and considerable danger, I feel really like it's interesting out there. I mean, some days I just go to simple terrain because then you can just kind of ride and you don't have to do precise route finding. Whereas in the yellow, basically what that means is you need to be pretty precise about your selection. And if you're not precise, you can get into trouble, right? So when they look at avalanche fatalities, there's almost no one that has died in the green. Like there might be a one or two exceptions over, tens of years. However, in the yellow, there's, a fair amount of people that have died in the yellow. So we need to have more knowledge. That's why you're taking this course, right? We need to have more knowledge to be able to travel in the yellow. And what do we need knowledge about? Well, a lot of things. But the first thing that comes to mind is the avalanche problems. We need to understand what the avalanche problems are and where they're located, so that we can understand the likelihood and the potential consequences of avalanches in those, in the layers, the avalanche problem, and whatever it is that might cause avalanches, right? Whether it's wind slab, storm slab, persistent slab, whatever it is, even cornice release. And then I will say something about the red here, and that is that it's possible to ride in the red and come home safe. As a matter of fact, it's likely that you'd come home safe even if you went, say, into challenging terrain and high danger, or complex terrain, even in high danger. However, if you do it often enough, you're going to run into trouble, guaranteed. So we're talking about margins of safety. Going into the red is like driving with icy roads in a winter storm with bald tires and not wearing your seatbelt. How's that? You think that's that's reasonable way to say it, Nick?
Yeah, I think that's pretty good. You're kind of just not taking the advice from the snow and the conditions and doing your
Yeah.
own.
Doing your own thing. Yeah.
Yeah.
I mean, most people don't do that. But yeah, when I was young, I remember driving around with bald tires, not out here. I was back east, but because I thought I was saving money. Luckily, I got through it. Just trying to think if there's anything else that we want to say, Nick, about the trip planner here before moving on. Kind of wanted to, really immerse people in it. And oh, the last thing I wanted to say, it's so funny, I was saying this on the weekend, and it's like, it's never the last thing, but maybe for this slide, the last thing I want to say is that AST2 is really focused in on this yellow. We're really going to spend time addressing what are the things that we need to understand in order to do this. Now, you may say, well, I don't know if I should take the course because I'm actually pretty happy staying in the green. This will certainly teach you more about the green and all that sort of thing. And at the same time, this is where it's going to be quite interesting, is this question of what should I ski, what should I not ski? And last year was a really tricky year, and so that's why we're going to, spend some time always reflecting on last year, just like we've been doing here today, and I'm about to do. Any questions before I move on, or any other comments? I'm not going to say you got to memorize it, but you should memorize this. I mean, you should always have this sort of in mind, and you will. It's not difficult. There's not much to memorize. Extreme is all red, high is only yellow, and then this moderate and low are actually pretty much the same. I mean, there's a curve here, but basically moderate and low are yellow, and complex terrain green, and challenging simple. Considerable goes green, yellow, red in the three terrains. It's not that much to remember. Okay, so I'm not gonna, because I showed that before, I'm gonna focus on moderate danger for a little bit. So this was the forecast on January 9th last year. This was the forecast, sorry, what the heck is it? On December 29th. So as I said, that video was December 9th. By December 29th, things were starting to get sketchy out there. Because the amount of snow on top of the weak layers, there was a November issue, like similar to this November, surface horror and facets. Seth, do you care to maybe take a stab at describing in a couple sentences what facets are?
For me, I think for the most common thing is just sugary snow.
That's a great way to say it.
Yeah, when you like shake it, it kind of moves like if you were to pour table salt in your hand.
Yeah.
It kind of moves like how table salt would move in your hand. Is that a good way?
Yeah. And Tom, do you know how facets are formed? It's okay if you don't. It's not really AST1.
Yeah.
And Jeff, Danielle, either of you guys? Andy?
I'll throw a guess out there. Just drying out and getting that kind of loose, dry stuff.
Yep. That's part of it for sure.
Is it the temperature differential through the layer?
Yeah. So temperature gradient. Tandy, anything? Do we lose Tandy?
Here,
Oh, okay.
I think just, yeah, older snow that's buried in the snowpack tends to facet under certain temperature conditions.
Yeah, so it's the combination kind of what Tandy and Jet, well, kind of what you've all said, sugary and the gradient affects faceting, and this whole idea of temperature gradient is not like crucial. Don't stress over it. It's like, but what's the because we're still learning about it, right? It used to be thought, oh, we take temperatures every 10 centimeters in the snowpack. That tells us what the temperature gradient is, and then we know whether the snow is faceting or more bonding. And some of the recent stuff is like, actually, that's sort of true, but if there's like this micro gradients that happen in the snowpack, and that actually is one of the bigger drivers of faceting. And so, this is the worry of, PhD master students, so we don't need to concern ourselves. However, what we do know is that when the difference between the ground, who can shout out first, what's the temperature of the snow at the ground, just above the ground? It's always the same.
0.
It's always at 0. Because the ground is warmer than 0. I mean, obviously the ground can freeze in some conditions, but generally once you get a snowpack on top of it, then there's this thing, it's called the earth. And the earth is like got a lot of what's called thermal mass, like it's big. And so because it's connected to itself, that thing, which isn't frozen, generally, as a matter of fact, the middle of it is like hot. But generally the ground near the surface is around 10 degrees, like as a rule, except like this time of year, the frost can penetrate it, but generally it's around 10 degrees. And so it's going to keep the snow. It's not enough to melt the snow at the bottom, because it takes actually, I'm getting a little sciencey on you here, but it takes a lot of energy to turn snow from solid to liquid. And there's not enough energy in the earth to do that, but there's enough energy to keep the snow at 0, right? Unless there's like just a tiny bit of snow and the air temperatures like penetrate it. So once there's a snowpack, we know that the temperature of the snow at the bottom of the snowpack is 0. Then the temperature at the top of the snowpack, once we have more of a real snowpack, roughly simulates the air temperature. Roughly, there's some cool stuff that happens, so to speak, with clear skies and all sorts of things. But roughly, it approximates the air temperature. So in an environment, and this is kind of important, I think, because this is sort of what helps explain why the snowpack in the coast is generally different from the snowpack in the Columbia Mountains, which is generally different than the snowpack in the Rockies. And I think for you, Seth, that should make sense, because I think the Selkirks in Idaho are part of the Columbias. I don't know if you ever call them that. You probably just call them.
Yeah, I've started to call them the American Selkirks, like the mountains near
the American
Sandpoint.
Selkirks, right? But
Yeah.
the Selkirks are part of the Columbias, because we've got 3 mountain ranges in what we call the intercontinental ranges, which are the Monashees, the Selkirk, or the Selkirks, and the Purcells. There are some other sub ranges. There's some stuff in the Okanagan, but we'll just keep it simple. There's the coastal mountains, there's the Columbia, which include those 3, and then there's the Rockies. And one of the reasons that they're so different is this whole idea of temperature gradient, because the temperature of the ground is 0. The temperature of the coastal mountains tends to be a little bit warmer, and the snowpack in the coastal range tends to be a little bit deeper. And so the combination of slightly warmer and deeper means that the difference between, and let's just pick a number here, if the average coastal snowpack is somewhere around -5 on air temperature, and you've got, like, say in middle of winter, an average of 2.5 meters, that's a pretty shallow temperature gradient from -5 to 0 over 2.5 meters. Does anybody have any questions about that before I move on? Because I'm going to now start talking about the other. Does that make sense? Shallow to
Yes. So you're just saying for the coast mountains, you have a smaller temperature gradient over
small
a
temperature
taller
gradient goes
snowpack.
from 0 to -5 over a lot of distance of snowpack, right? Okay. Now we move to the Columbias, and let's say the average snowpack middle of winter is 2 meters, but the average temperatures at night are more like -10, maybe even -15 in some locations, more like -10 down in the southern part here. And so there's a bigger temperature difference, 0 to -10 or -15, over less of a snowpack, only maybe 2 meters, right? And so there's a little more temperature gradient that can drive this idea of faceting. Now we move to the Rockies, and average snowpack, middle of winter, meter, meter and a half, depending on the year. And the average air temperatures are probably closer to -20, right? So you've got a much bigger temperature difference over a smaller snowpack. And so there tends to be a lot more faceting in the Rockies. And those are important drivers for the difference between those three snowpacks. Now, like I said, this whole idea of temperature gradient is still being researched. And there's a lot that has to do with these that the temperature gradient over a centimeter is actually more important than the temperature gradient over the whole snowpack. And one of the reasons that we discovered that is because we always knew that why is it that facets really love to form around crusts? And one of the reasons is that there tends to be more of this sharp micro temperature gradients around crusts. You guys still with me? That's a bit of a deep dive, but I think it's so valuable, right? Because then, thanks, Seth, then you understand, right, why the coastal range is generally different than our range, which is different from the Rockies. And depending on the winter, right, the more it's cold and shallow, the more faceting is going to be taking place in general. The more it's a little warmer and deeper, generally the more stable the snowpack's going to be. Generally. I mean, we haven't talked about individual weather events, surface hoar, crusts, but as just a general way of looking at things. Okay. So last year was quite cold, right? For, a climate changing Earth. It was quite cold in our region. And we just never really got to a very deep snowpack until March in some locations. And some locations really never got deep at all. So it was an important driver toward a tricky snowpack that claimed, more fatalities than we've had in many, many years in Canada. And, that being said, I think I brought this up in the webinar. Backcountry recreationists did a heck of a good job last year managing that tricky snowpack. Because generally, on average, we have about, these days, the 10-year average has been going down. I think we're maybe around 11, but last year would have bumped it back to 12 maybe is the average number of fatalities. And in a typical year, there's maybe like 2 or 3, like 1, maybe 2 accidents that happen in the commercial realm. And then the rest are recreational riders, both, backcountry skiers, snowmobilers, sometimes snowshoers, ice climbers, anyone that's exposed to avalanche terrain. And Seth, of course, I'm talking about Canadian numbers because I'm familiar with them. All these principles apply in the US on a different scale. The numbers are higher there, obviously, because we're talking about more people and bigger area. So last year, I might be off here on the number, but I think it was only like about 6 or 7 that were recreational, and the rest were through commercial operations. Now, this isn't to slag the commercial operations, the heli operations that had a very high number of fatalities compared to what their norm is. It just shows how tricky the snowpack was because professionals were making mistakes. And recreationists were doing a pretty good job, partially because they were scared. Because the media coverage last year was unprecedented. The media coverage, warning about avalanches and how bad the snowpack was, if anything, was a little over the top, in my opinion. Because when they're saying this is the worst snowpack in 30 years, blah, 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 I was like, I don't actually think it is. I mean, it was pretty bad. And it's hard to say exactly where it falls in, but I don't think it was the worst. In any case, people were running a little scared. So going back to this story, December 29th, things were going off. There was a fair amount of snow coming down. So there was a lot of new loading on top of these weak layers. There were a bunch of surface hoar layers that formed in dry periods in December. There was the issues with the November facets and surface hoar that formed then, like we have facets and surface hoar right now. We'll see what happens. And then things started to mellow out a little bit because it wasn't snowing as much in early January. And so then we got to January 9th, and there weren't very many natural avalanches. A few human-triggered avalanches were still happening, but the amount of avalanches that were happening had decreased enough that the forecasters dropped the bulletin to moderate. Now, they didn't get rid of the avalanche problems, which were persistent slab, depersistent slab. So the persistent ones were the surface hoar issues, right, from December. The depersistent was the November bad layer. And then, there was some wind activity picking up old snow and forming some wind slabs. So still a layer cake of a snowpack, not a good snowpack in general, but not enough avalanches to call it considerable. Like if we look at the definition between considerable and moderate, this is so great. You guys still doing okay? I'm talking a lot. I'm gonna, try to get you guys involved. But this is just so good. They're both potentially dangerous, but careful snowpack evaluation, cautious route finding, and in moderate, it's still heightened avalanche conditions on specific terrain features. That's kind of where things change. Considerable is fairly widespread, typically. Moderate is a little bit more like in certain places. Natural avalanches still happen in considerable danger. Human triggered are actually pretty likely. So it's still a pretty, it's considerably dangerous. But by the time you're at moderate, natural avalanches aren't so likely. And that was what was happening in that period, you know, in early January. But human triggered were still possible, right? So I think I also mentioned this in the webinar, that way back when, avalanche forecasters didn't follow this very strictly. They would follow it more like, we're really worried about this snowpack, so we're going to just keep it considerable, even though, you know, natural avalanches really have not been happening, and human triggered are more possible than likely. We're just worried about the public, so we're gonna keep the danger higher. And you might be thinking, yeah, geez, go for it, dudes, like, and gals, like, you know, just use your judgment. You don't have to be so accurate. However, the current culture in the forecast team is to be accurate with their forecasts. And the reason that's good is that people pay attention to the forecast more. The danger of just sort of kind of trying to anticipate what the backcountry public is going to do and keeping the danger maybe a little bit higher than it is that then people are dismissive of the bulletin. I mean, I remember lots of people, backcountry travelers, saying that 15, 20 years ago. The bulletin, right? They're just, you know, they always keep it higher than it is. And so, you know, then you've got a situation where you can't trust the bulletin, really. Now you can trust the bulletin, and moderate danger. So this is the part that's tricky. Here's the trick. Here's what I'm about to say is the $1 million thing, or at least $2.30 worth. Moderate danger in a, you know, more kind of straightforward snowpack that, you know, doesn't really have a lot of trickiness to it. It's like, you know, it has some issues, but it's not nearly as tricky as last year. Kind of like before last year, what we had for several years in a row, and what many people were used to because they've only been, you know, riding in the backcountry since 2019, 2020, when COVID hit and so many people got into it. You know, they were used to moderate danger being, you know, not that bad at all. But last year, moderate was a pretty serious thing. And that's why people were getting caught out. My opinion, but I'm sure there's others that. What do you think, Nick? You think that's fair?
Yeah, I think you're right about it. It's scaring a lot of people. Like, I know a lot of people that I skied with wouldn't even go out in anything over moderate, and they would normally be comfortable skiing, you know, inconsiderable and pushing the limits. But I think yeah.
So people were scared, but it did catch some people by surprise, right? Because they're like kind of used to moderate being not so bad. And on January 9th, nobody had died. You know, there had been some special public avalanche warnings because, you know, it's like, hey, this is a special snowpack. We're going to give some special warnings. But so when the 2 RCMP officers died in this avalanche, the first fatalities of the 22-23 season, people were surprised, and there was a lot of coverage. Just, you know, to go back and look at moderate danger, you know, the guidance for moderate danger is simple terrain, good. Challenging terrain, probably pretty good. You still want to use some caution. And complex terrain, maybe, you know, like maybe you go into complex terrain. As I said, the key to yellow terrain is really thinking about the problems. And sorry, this is pretty hard to read. So I'll try to read some of the pertinent points. In the persistent slab, surface hoar facets, crust, 40 to 70 deep, which is a prime depth for human triggering. This layer has been most problematic around tree line and lower alpine elevations and has produced some large avalanches. So it's not everywhere, but in certain locations, it's been, yeah. Keep terrain selection conservative in these elevation bands and practice really good travel habits to reduce your exposure. Like that is so spot on, right? This is an accurate forecast. The deep persistent slab, large and weak facets sit near the base of the snowpack. This has been recently been problematic in lower alpine elevations. Avoid thin and rocky start zones where weak layers sit closer to the surface. Do you guys get that? The problem with shallower snowpack is like this layer, the deep persistent slab, where there was sort of average snow depth was pretty deep, like, you know, almost 1.5 meters. So it's pretty hard to trigger that layer where it's 1.5 meters. But as you know, the snow is not uniform everywhere. There are certain locations where the snow is going to be shallower because of the wind stripping it, right? And so their recommendation is to avoid thin and rocky start zones where weak layers are closer to the surface. Sorry, I'm just barely able to read this. Riders are most likely to trigger an avalanche on this layer in terrain with shallow or variable snow depths. I mean, it's prophetic, right? And then there's a wind slab problem too, but that wasn't the main issue here, I don't think. Shallow, rocky, upper tree line to lower alpine. That's exactly where this is. So what I'm saying is that in many years, yellow is not too bad, and you can often get away with going into the yellow without being like really vigilant about what are the avalanche problems. But in a year like last year, and really in any year, if you're going into the yellow, you got to read the details about the avalanche problems to keep your margins of safety reasonable. It doesn't mean that you can't go into avalanche terrain. Absolutely you can. But you need to know what the problems are and where those problems are going to be most problematic. Sorry for being redundant. I've been looking forward to, I mean, not looking forward to talking about people dying, right? I talk about deaths with a great deal of respect for the people, the families involved, many, many people impacted. And at the same time, as an avalanche professional, we can learn so much from these accidents. It's a wicked learning environment, the whole avalanche thing. So many times we just don't know how close we were to triggering an avalanche. I mean, unless we trigger one. But most of the time we don't. And is it like, oh yeah, we skied that terrain, it was safe, it wasn't like, you know, that dangerous, it was a good choice? Or did we ski that slope and just get lucky? We just didn't hit the right spot. And so we can have bad habits get reinforced because of this wicked learning environment. That's a term for something that doesn't give you really reliable feedback. And the snow does not give us reliable feedback. So I've been looking forward to teaching courses this year because last year was such a great teacher. Such a great teacher. Because we really had to be paying attention to these avalanche problems in order to go into the yellow. We didn't need them as much to go into the green. I mean, I'm not saying that it doesn't help to read the bulletin. Of course it does. But in the green, it's less crucial. Whereas in the yellow, when you're dealing with especially persistent and depersistent issues, it's tricky. It's really tricky. So we have this opportunity this year to learn from that. Okay, I'm going to finish up a little bit more talk about this because it's not just about being conservative. It can be, you know, it's up to you. You can just take a much more conservative approach in general, right? Some people, I've taught courses to people that basically always ski in the green. They just don't want to push it, and that's fine. They have a good time out there. You know, they have a great time out there, actually, because they don't have to, you know, they love the flow of skiing powder, and, you know, they don't have to be so concerned if they're not in avalanche terrain. They don't have to go one at a time. They can just party ski and have a great time out there, right? So there's nothing wrong with being conservative. At the same time, many backcountry skiers want to go into bigger terrain, complex terrain. And there's times to do that. But many years we have to spend part, or in some cases like last year, most of the season being patient. Still skiing great snow, still finding great terrain to ski. But in terms of the big terrain, you know, the complex terrain, I wasn't going there until things started to get more stable. And by the end of March last year, this was the avalanche bulletin. The deep persistent problem was still there. And so I was still having to pay attention because we're still dealing with moderate danger, especially in the alpine. Dry loose is slough, easy to manage. But the deep persistent slab, weak layer of facets near the base of the snowpack, the likelihood of human trigger is low, given the layer's depth, right? So now this is a forecast for the Selkirks, right? And I think the Monashees were the same. However, the Purcells and the Rockies did not get this stable because they had a shallower snowpack, right? So it was much easier to trigger those deep layers. As a matter of fact, there was a trip toward the end of March, middle end of March, that my buddies and I were planning to the Purcells, and we decided to cancel the trip. And we went instead to the Selkirks, where the snowpack was on average 3 meters deep. Whereas in the Purcells, where we were planning to go, it was about 1.5 meters. And so we ended up choosing a snowpack that was just much more stable. Okay, so low, large triggers, cornices, smaller avalanches have the potential to produce. So, you know, steep, shallow, rocky terrain are the stuff to avoid. So this is what we skied that day. Is everybody familiar with these slope overlays and what they mean? Tom, what on average would this color be? Slope angle. Just roughly, you don't have to know exactly.
30 degrees or higher.
Yeah, well, and so the way that these things work is the yellow is like close, but just under 30 degrees, and then light orange is over 30, but by the time you get into like the darker oranges, you're into like the 35 to 40 degree terrain. So it's prime avalanche terrain. And
Yeah.
this is, let's see, I think it was the blue line was what we skied. So we started up here on a glacier and then skied into lower alpine and eventually into tree line. So the upper part of the run, not too bad, but this part here, you know, we're exposed. But you can also see that we're in a little bit of a gully. You'll see the picture of it. It's not a horrible gully, but it's a place where the snowpack is relatively deep. You know, we're not out on some sort of exposed ridge where, you know, there's a lot of shallow snow. You know, well, I'll tell you, it's beautiful skiing. And then our out was climbing up the bottom of it and then kind of avoiding the worst part of it by climbing up here where it's less steep and then getting up here where it's relatively safe, a bit of overhead hazard here, but relatively safe up here compared to climbing up this way. Does that make any sense as you guys are looking at the colors here? I mean, we're going to spend a lot of time on this course talking about route finding, but you know, like to me, I know the terrain, so it's like, oh, well, you know, duh. But you know, you can see how the colors are darker, the topo lines are closer together. You know, this is maybe our down. We move through the terrain quickly, one at a time. But going up, you need a greater margin for safety, right? So you want to obviously look for the less steep. And one of the challenges of going into this place in general is it's like, where the hell are you going to come out? I mean, look at this. This is steep, you know, this is steep, this is steep, like, you know, so this is the best option, right? You just have a little bit lower slope angles, a little bit less overhead. And once you get up here, you can kind of get up on a little, you can sort of see there's a little bit of high ground right through here if you understand the way contour lines work. Okay, so we'll just watch this video. This is working, and then we'll wrap it up.
Hey, this is Keith Robine from Kootenai Avalanche Courses. It's March 28th, okay. 2023, and yeah, the last time I did a video, we were more in the middle of winter, and now we're getting toward the end of March, and things are changing. How are they changing? Well, obviously things are getting more spring-like, but well, we had minus 20 last night, so winter can still do its thing and keep the snow good, particularly on those more northerly aspects, which is what we just skied here. And just wanted to talk a little bit about earlier in the winter. It's been a winter for being patient, and it's one of the things that we talk about in terms of human behaviors that helps us stay safe in the backcountry. And yeah, patience has kind of been the name of the game. And you know, we were just saying, wow, we just can't imagine that we'd be skiing lines like this later in the season, but sure enough, you know, we just had to wait. And you know, we've got a pretty good snowpack here. We're in the Selkirks. We've got close to 3 meters, and you know, the danger of a deep layer release isn't completely gone, but it's so much less now that the avalanche bulletin is down to moderate, low, low in the 3 different elevation bands. And so it's really only in the last week or 2 that we've started to step cautiously into bigger terrain, and we've pretty much avoided all of this terrain the whole winter. And how are we doing it? Well, just like any other day, we're using the daily process. We got the forecast, which, as I said, is moderate, low, low. We planned, you know, where are we going to go today? We're avoiding areas which is more shallow areas. That's where the avalanche problem is, the potential deep layer. We're avoiding that kind of stuff. We got the right gear. We're verifying conditions by, you know, having the visibility of a day like this to do this kind of a tour. You want to be able to see, you want to be able to notice, you know, do I see signs of other avalanches? And that's been a a green light check for us today. You know, we're using good travel habits, spreading out where appropriate, and picking slopes where we feel like we can, you know, obviously step into bigger terrain, but also think about where's our escapes, where's the high ground. And right now we're up on a little bit of a high ground feature, not totally safe, but safer than if we were down in a gully. So yeah, hopefully that's helpful to be thinking about how the snowpack changes over a season. It's been a challenging year, but also a good year. There's been lots of great powder, and I don't know, we had 7 overnight, 20 over the last few days, minus 20 last night. It's very nice skiing.
Okay. You guys can hear me again? I want to say just a few things, and then I want to hear your comments. The way this is presented tonight, it can almost seem like this Keith's really full of himself, you know, and he's really tooting his horn, you know. He stayed conservative during part of the season and then got aggressive in another part of the season, and maybe he was just lucky, and maybe, you know, I was just lucky. I have a lot of humbleness around the fact that nature doesn't follow our rules. You know, nature does what it does, and it's not a question of no risk. It's a question of reduced risk. It's a question of avoiding things when the risk gets too high, and it's a question of stepping into things when the risk gets low enough that it's a reasonable choice. So this course will teach you what and where to avoid when things are on the riskier side, what, where, and when. And we'll also teach you what, where, and when to step into bigger terrain. This will help you gain confidence so that when you do step into bigger terrain, it's with the knowledge that the risk has gotten low enough that it is a reasonable choice. And it's a little bit hard to take all of that in because it's just words. You will take it in as you learn and practice the skills that you're going to get in AST2. Okay, so don't worry that it's like, you know, what Keith's saying kind of makes sense, but I don't feel it. Of course you don't feel it. You got to do it to feel it. And that's what we're here to do. You know, that's what's going to happen. And then after the course, you know, you're going to have opportunities to ride. And, you know, maybe we're dealing with a tricky snowpack, and maybe we're not able to get into big terrain like last year until later in the season. Well, you know, hopefully you'll have that opportunity, and then we can talk about that. You know, last year's AST2 group, that's exactly, you know, what was happening for them. They were waiting, they were being patient. And then when the time was right to step into bigger terrain, not with no risk, but with greatly reduced risk compared to earlier in the season, you know, they did. And then it was great. You know, we were able to talk about their route plans and where they went. And, you know, they were fairly new to it. So it was like, what do you think? And, you know, and they had that kind of mentorship that this course will provide. So I hope that gives you a little bit of a taste for, you know, what's possible. Because, you know, this is not just a 4-day course or a 3.5-day course. This is a whole season. So there's a lot of possibility here, and I just want to encourage you as much as you're able to you know, take advantage of that. Whew. And I couldn't do a deep dive like we did tonight in a classroom, you know, because I'd be more concerned about, oh, I got to move to the next slide. But, you know, I got on a roll, and, you know, it sometimes happens and sometimes it doesn't. But the way that we were able to talk about it today felt very genuine. And I don't like using the word accurate, but I think it was very descriptive of last year's problems. You know, who knows what's going to happen this year, and you know how we play this game of backcountry riding with this, you know, indeterminable, somewhat predictable risk. That's avalanches.